This video will be on compositions of transformations. So on this first slide, what you see is that there's on the coordinate plane, you're going to see three different shapes here. That's a composition. There's two or more isometries, and we've already discussed isometries, and that's basically, your reflections, your translations, and rotations. So we want to identify our pre-image, and looking at the coordinate plane that's provided for us, the pre-image is the one that's in blue, and I know that because it does not have any prime symbols next to it. So a composition of, like I said, of transformation is going to consist of two isometries. All of the images should be congruent. So I have a first image and a second image. Let's recall that your isometry transformations, they're rigid, and so therefore they preserve the size. So in this type of example that's shown on this coordinate plane, this is called a glide reflection. Glide is synonymous with translation and then of course reflection. So we're going to go to our original pre-image, like I said, in blue, and then you're going to glide over to the red triangle, and then from there you want to reflect over the x-axis. You have to be specific where you're reflecting from, so when you're writing it out, make sure that you notate that. So if you notice underneath this coordinate plane, it actually is written out, the directions. So it says triangle ABC is translated to form triangle A prime, B prime, C prime. This triangle is then reflected over the x-axis to form triangle A double prime, B double prime, C double prime. Now pay attention. They said that triangle is then reflected, meaning that it does not go back to your original pre-image. So it goes from my pre-image to the first image. Now I take the first image and then I follow the directions for the second transformation. Again, this specific type of transformation is called a glide reflection. That's when you have a translation first and then a reflection. So I'm going to also show you some more examples when two or more transformations are combined to produce a single transformation, and that's again called a composition of transformations. And then the last slide is going to be showing you the order in which you should actually follow the transformations. All right, so for example 1, we're given the described glide reflection below. Find the new coordinates when A has x -2 and y 5. So the description that is below or here is my translation. So translation, and this time it's not written in words, it's showing you the arrow notation rule. So I see that I'm going to change my coordinates x, y to subtracting 3 from my x and subtracting 3 from my y. Well, when I do that, I have to go back to my pre-image coordinates and I have to follow those directions. So my x is the first one, so -2 plus -3, or -2 minus 3, however you want to read it. And then I'm going to take my y, which is 5, and it says to subtract 3 from it. So if I did that, I'm going to have a -5, +2 for my A prime this time. Notice that it says prime. Make sure you distinguish that when you're writing it. So A is my pre-image, A prime is my first image. So now I have another set of directions. It says to reflect or reflection across the x-axis. So my rule for that is I'm going to keep my x value the same, but my y value I'm going to multiply times -1. So I will look at my A prime though. I'm going to keep my x value the same, which is -5, and I'm going to multiply my y by -1. So my A double prime would have coordinates of -5, -2, and I'm finished with that one, and that was called a glide reflection. So my next example is describing. This time it says describe. That means I'm using words. I'm not writing rules. I'm just using words. So describe the composition of transformations shown below. Well, I am already provided with a graph, well, 3 graphs of segments on this coordinate plane, and I've also noted the signs that are in each quadrant. So this is the second quadrant, which has x as being negative, y is positive. The first quadrant, both x and y are positive. And then the fourth quadrant, your x is positive and your y is negative. So again, and I've taught this in class, but for your quadrants, you have 4 quadrants and they're all worth 90. So 90 for the first. If I move over here, another 90. If I go down to the third quadrant, 90. And then to the fourth quadrant, 90. Notice I was going counterclockwise. That's how you actually reach your quadrants. All right, so since I want to describe it, I have to first know where my pre-image is. So if I look at it, I have 3 different colors here. And my pre-image for this one is going to be PQ, segment PQ, and it's vertical. If I look at the actual coordinates for that, I will notice that it does fall into the category of a negative X and a positive Y. That is very important when you're doing transformations. You want to pay attention to the quadrant signs. Wherever your graph is or your point, that's what you're looking for. You're making sure that your coordinates match up with those signs. So now I have options because again, this is an isometric type situation if I'm trying to do a composition of transformations. So I could either reflect, and if I reflect it, that would mean that it would be vertical. I could translate, same thing, it would still be vertical. And I can also rotate. But then I have to be specific. How am I rotating? How many degrees? Well, we know we're going to be about the origin for this particular video, but I am going to be rotating and I just need to know how far. If I'm currently in quadrant 2 and I see that my prime is in quadrant 1, that means that I went 90 degrees and look which way I'm going. I'm going clockwise. I could also take the scenic route and go 90 plus another 90, which is 180, plus another 90, which is 270. But this time I went counterclockwise. So 270 degrees counterclockwise and 90 degrees clockwise have the same rule. And if we go on to see what those coordinates are, we can see what the rules are. So here I see that my P prime has now become positive 1 and 1, X and Y. And then my Q prime has become positive 5 and positive 1. Again, if I'm looking at my quadrant signs, I see that both my X and my Y's should both be positive. If I'm trying to figure out the rule, when I rotate it, I actually rotated my Y's and my X's, right? So this Y went towards where my X position was, and then my X went towards where my Y position was. And again, I'm following the signs of the quadrant that I'm in. So I took the 5, I moved it to the first position, which represents my Y, and then negative X. But once I multiply this one, it's going to turn into positive. So Y, Y, X, and then I took this X and I multiplied it times a negative 1. So that's what happened there. And again, if you can't remember that, just pay attention to your signs here. Both of these should be positive. Okay, so now, once we get to this point, we're doing a composition. So we know that we're gonna move again. I could either reflect, which here, if I did reflect, it would be like somewhere in between. That's probably not what's going on here. I could try to rotate, but if I rotate it, it wouldn't be horizontal anymore. It would be vertical because it's rotating. And then my other option is to translate. And again, I would never select dilation because that's not an isometric transformation. We're only looking for those that fall under that category. So in this instance, I would actually have translated down by 3. I look and I see that my X values remain the same. But if I were to subtract 3 from my Y's, I now have these new coordinates for my P and my Q double prime. So to sum it up in words, because that's what it's asking, if I am to describe what's happening, there was a rotation 90 degrees clockwise at the origin. I have to be specific as to the center, and then a translation down 3 units. So again, you do not have to say 90 degrees clockwise as well as say 270 degrees counterclockwise. You can say one or the other because they have the same rule. And then for example 3, we're asked to show that each of the following pairs of figures are congruent by describing a mapping of the original, which is our pre-image, on top of the image. But if I'm looking at this, I see that my pre-image does not have any prime symbols, but this one has a double prime. What happened to my prime? That's what we have to find out. So we're going to describe the composition of transformations shown. So my strategy would be to find any one of these points and try to match it with the double prime coordinate. So for me, C looks like it's fairly simple to match up. So if I'm looking at that, all I would have to do is translate down. But because this graph is not specifically on a unit, a tick mark, I'm just going to say translation, but normally you would have to be specific and say like translating 3.5 units down, something like that. So here what I'm going to do is I'm going to just translate down, and then I'll notice if I did that for each one of my points, that D is on this side. Yes, they still have the same Y value, and so is A. However, they're not mapped on top of each other, and that's what we're trying to do. So in addition to translating, I would also have to reflect it. And then notice where I'm reflecting it this time. It would have, if my C and C double prime are together here, if I reflected it, they're going to have the same point. But the D would have to swing over, and the A would have to swing over, and the B would have to swing over or reflect over the Y axis. So that's what's happening there. Two things are translation first, and then a reflection over the Y axis. And then the last thing is, whenever you're given the rules and they're not written as an arrow notation, but they're written in a notation that looks like this, where you have this open circle, you have to understand that order does matter. You have to follow the directions of what's after that open circle first, and then go to what's in front of that open circle and do what they're asking you to do at that time. So order matters. All right. Well, I hope you enjoyed this video. If you learned anything, go ahead and like and subscribe. Have an awesome day.
Subscribe.